These are the trends in the cloud computing. User required for the high data rates and quality of services are exponential increases. As I told you that the number of applications are arriving where the technology, where the IoT can be adopted. Because of the various applications, various reasons, the high data rates and the quality of services are the main part of this cloud computing. Then technological evaluations in a smartphone, IoT devices, sensor and actuators enable the new high advanced services and applications. So the technology applications are coming up. Suppose your wristwatch, the new applications are coming up. So for that, the different type of data is there. You have to route that data and you have to post that data to the cloud. Our new IoTs and the mobile devices have the more powerful CPUs. As I told you, the mobile and the IoT devices are the CPUs, GPUs, TPUs, and other the processing units are there. They are capable enough to sense the data, to store the data and process a small amount of data, not the large data. It can process a small amount of data. So that is a trend in cloud computing. And why do we need the cloud computing? We need the cloud computing. So however, the CPUs are not sufficient to process all the data and provided the results in time. Your CPUs is smart enough, it has a capability of GPU, TPUs, but because we have the limited amount of power, limited battery power, so it is not able to process all the data. It processes a small amount of data, but it is not capable to process all the data. The optimal decision based on the comprehensive situation awareness are needed. In few cases, suppose you deployed a temperature sensor in a room. One sensor, there is a change in the temperature, sudden change in temperature is observed. So because of only the single sensors, you cannot send signals or you cannot control the situation. It may be possible that sensor is giving you the default reading. It may be the sensor get maybe the sensor get dead, or it may be that because of some condition the sensor is producing the wrong data. So before to take any actions, we first take the data from the nearby sensor also. What the nearby sensor temperature is there, and according to that we'll take the decision. So it is not only the single sensors which sense the data and we do the action. It is not possible. So what we require the data from the nearby sensors also, so that according to the situation we'll take the decision. So that is only possible on the cloud. So not all the data is available at the node. Obviously, collected data size is too big to compute at one node. When we continuously monitor the temperature, after every 15 minutes we get the value of the temperatures. So in a week or in hours or in a day, you'll have a lots of readings, lot of computed data. So to compute a big amount of data at the node is not possible. And as I told you, the limited battery energy restrict the fast and the large amount of computing. So what is the solution? The solution is that the mobile cloud computing. The first solution, the early stage solution is that the mobile cloud computing. The mobile cloud computing means we have the cloud, we have the sensors, but how to route the data to the cloud? So we use a mobile networks to route this data towards the cloud. So what is a mobile computing, mobile cloud computing? This allows the cloud computing to support the mobile and IoT devices. You can use a decentralized cloud through a core network, which could be like the internet or mobile communication network, and ask help from the mobile operator, such that you can go to the network, connect to the cloud, and ask the cloud to save the information or compute the result and deliver the results. Means you have the sensors. How to send this data? With the help of this mobile communication, we send this data to the nearby base station. This base station send the data to the LTE core network. With the LTE core network through the internet, we send the data to the cloud. That is known as a mobile cloud computing. We use a mobile infrastructure to send the sensor data over the cloud. So it is known as a mobile cloud computing. The cloud is a way over there. Then there are internet. Then there is a core network of the mobile communication structure. Then down here is what we call as a radio access network. So we have the radio access network here. Means to transfer the information from the user equipment to the cloud, we have to send the information to the base station. Means here we have to route the data first here, then we have to route the data to the core network, LTE core network, then to the internet, to the cloud. So various stages are there. So what is FIC? What is the major advantages of this mobile cloud computing is extended battery life because the offloading the energy consumption components to the cloud. We are not computing because the node is not capable. So with the help of this mobile cloud computing, we are sending the data to the cloud to process the data. Enables the faster sophisticated applications such as IaaS, PaaS and RaaS. Later part we'll see that what is IaaS, PaaS and RaaS. It's a profile services, the service sectors and the individual service sectors are there in the IoT. There are the three categories of services are there. So these are the categories of services. So for individual service, for product service and for the service to mobile users and IoT, and provide the massive data storage of the mobile user and the IoT system. So we have the cloud. The cloud has a large amount of the storage capacity. It can store the huge amount of data. It can process the data. So we require the application of this mobile cloud computing is that the sensor sends data, and with the help of this mobile infrastructure, mobile communication infrastructure, we process this data, we transfer the data to the cloud. And the cloud has a power. The cloud has a lots of processing power. It processes the data and is store the data if required. So that is the advantages of the cloud. Now, what are the restrictions and the characteristics of the cloud? The characteristics of the cloud is that MCC is that long time delay. The long time delay means you transfer the data from the base station to the LTE network to the internet to the cloud. Means a number of layers are there. The data has to pass with the number of layers. So there is a long delay and the quality of service performance. The high usage of network resources because every request will need to go through the mobile communication network and the internet, and then return and then a return must be received. Means for a small information, when you select this, when you sense the small temperature, that temperature has to goes with the different layers. Means from the base station to the LTE to the cloud. Means it has to pass through the various stages. So and if you are suppose we have the limited amount of data to be processed or data to be sent. Means we have the limited communication facilities now. We have the limited bandwidth. So in the limited bandwidth, if the number of sensors are huge, then it is very difficult to process or to send all this data through the limited network, even limited bandwidth. So that is a limitation of this mobile cloud computing. Then the high battery usage of the IoT and the smart devices because they are sending it to the local base station or something that connected them to the wide area network such that you can access the internet. It is required to access the internet or to transfer the sense data to the base station. Means it required a finite amount of power. When we use a Wi-Fi or when we use a Bluetooth, so it consumes power from the device. So that is a high battery usage of IoT and smart devices. Then the most important thing is significant packet interval inter arrival time jitter. That is a main disadvantage of this mobile cloud computing is that the delay bound variations. Means suppose you are processing some video applications. You are using this IoT for the video applications, and the video application means what? For a video you have to receive, for the high quality of video you have to receive the at least 40 frames per second to have a good quality of picture. But if the network congestion is there, the limited bandwidth is there, lots of users are there, lots of users are demanding into the same video processing. Suppose in case of release of Radhe movie, when it release and suppose crores of users are there and they want to watch this movie online. So this mobile cloud computing. So all they demand to the same kind of application, same type of this movie. So the same data has to process with the network and transfer to the users. But in some cases, it may be possible that for the high quality of picture, you have to receive the 40 frame per second, at least 40 frame per second. And because of this, a different path which is followed by this data to be arrived at the user end, there may be a mismatching of these frames. So it may be possible that there is some lag of this transmission of the data. और जब हम वीडियो जब वॉच करेंगे तो इट मे बी पॉसिबल दैट कि पहले वाला पार्ट पहले आ जाए, बाद वाला पार्ट बीच में आ जाए. ऐसा होता नहीं क्योंकि वी हैव द मॉडेम इन द टीवी, सो वो अरेंज कर लेता है साइड को. पर अगर ऐसा नहीं होता, मॉडेम नहीं होता, तो क्या होता कि आपको लास्ट वाला पार्ट, आपको जो क्लाइमेक्स वाला पार्ट है यूज दी फर्स्ट एंड जो पहले वाला पार्ट है वो आपको बाद में मिलता. तो इट इज बिकॉज ऑफ द टाइम चीटर, बिकॉज मोबाइल हैज़ अ लिमिटेड पावर, मीन्स मोबाइल नेटवर्क हैज़ अ लिमिटेड बैंडविड्थ, और लिमिटेड बैंडविड्थ में मुझे नंबर ऑफ यूजर्स को, सभी यूजर्स को सेम डेटा प्रोवाइड करना है. So that is not means useful when we have the large amount of users, large amount of IoT devices.